So we're going to have a look at a factors question from the 2019 Junior Cert Higher Level Paper 1. So it's question 2, and the first question asks us to write down 4 factors of 45 apart from 1 and 45. So a factor is a number that divides evenly into another number. So another name for a factor is a divisor. So something that divides evenly into another number and doesn't leave a remainder. So factors of 45 are 1 and 45. What are the other factors? Well, 3 divides evenly into 45. 3 goes into 45 15 times. 5 goes into 45. It goes in 9 times. And if 5 goes into 45 9 times, well then 9 must also be a factor of 45. And likewise, if 3 goes into 45 15 times, well 15 is a factor of 45. And so 45 has 6 factors altogether: 1, 45, 3, 5, 9, and 15. So what we'll notice is that generally the factors occur in pairs. So 1 times 45 will give you 45, 3 times 15 will give you 45, and 5 times 9 will give you 45. But we'll see in a later part of a question that that's not always the case. If you take a number such as the number 9, 9 has factors of 1, 3, and 9. And so whilst 1 and 9 are a pair of factors, 3 multiplies by itself to give the number 9. And so that's important in a question that's coming up. The B part of the question tells us that n is a whole number bigger than 1 and it has just 2 factors, 1 and n. And we have to put a tick in the correct box to show what the name of this type of number is. Is it a composite number, a prime number, or a square number? So a number that has only 2 factors, 1 and itself, is called a prime number. So any number bigger than 1, where the only 2 things that divide evenly into that number are the number 1 and the number itself, we call that a prime number. And so the answer to this question is prime. What's a composite number? Well, any number that's not prime is composite. So for example, prime numbers are 2, 3, 5, 7, 11, etc. So numbers where the only factors are 1 and itself. All of the other numbers, 4, 6, 8, 9, 10, etc., they all have factors of 1 and the number itself, but they also have some other factors. So for example, the number 6 has factors of 1 and 6, 1 in itself, but it also has factors 2 and 3. And that's the case with all composite numbers. A square number then is a number that has been found by multiplying an integer by itself. So for example, 1 squared is 1, 1 is a squared number. 2 squared is 4, the number 4 is a squared number. 3 squared is 9, 9 is a squared number, and so on. As we go through all of the integers, we find all of the square numbers. In 2 part C, we're told that p is a whole number, and apart from 1 and p, the only other factor that p has is 7, and we have to work out the value of p. So this is an example of a number that has an odd number of factors. We have the number 1 is a factor, the number 7 is a factor, and p, the number itself, is a factor. We saw previously that the number 9 had 3 factors. It had a factor of 1, 3, and 9. And so whilst 1 and 9 make a pair of factors and they multiply to give the number 9, we had to square the number 3 to give 9. 3 squared is 9. And so this is a similar example where we have an odd number of factors. 1 times p is obviously p, but the number p then can be found by squaring the other factor, 7. So p is equal to 7 squared, p is the number 49. So if we have a number that has an odd number of factors, well then one of those factors has been squared to give the number itself, and that's the case in this example. So in 2 part D, we've been given the algebraic expression 12k plus 8, and we've been asked to find 4 factors of this expression. So clearly 1 is a factor, and 12k plus 8 is a factor. We've already gone through that a number always has factors of 1 and itself, but we need to find the other factors. And so we're going to use the common factor method of factorizing to find 4 other factors. So the first thing I'm going to do is I'm going to write down the expression 12k plus 8, and I know that the number 4 divides evenly into 12k and divides evenly into 8. Now the question is, how many times does 4 go into 12k? Well, 4 times 3k is 12k. And how many times does 4 go into 8? Well, 4 times 2 is 8. And so this is called factorizing by using a common factor. And what is that common factor? That common factor is 4. We can check this by multiplying it back out. 4 times 3k is 12k, and 4 times 2 is 8. So what else divides evenly into 12k and into 8? Like, what other common factor is there? Well, the number 2 is also a common factor. 2 will divide into 12k 6k times, and 2 divides into 8 4 times. And so 2 is also a common factor. And so what are the 4 other factors other than 1 and 12k plus 8? Well, we have the number 4, we have 3k plus 2 is a factor, we have 2 is a factor, and we have 6k plus 4. And again, they occur in pairs. 4 times 3k plus 2 would give us 12k plus 8, and 2 times 6k plus 4 would give us 12k plus 8.